This video we are going to analyze a continuous beam ABCD. AB is having a span of 3 meter and BC is having a span of 4 meter and CD is having a span of 4 meter, and a point load is acting on AB span of 80 kilonewton and uniformly distributed load of 50 kilonewton per meter is acting on BC span, and 40 kilonewton point load is acting at the center on the CD span. Now we are going to analyze a continuous beam in Etabs. Click on New Model. Select Use Built-in Settings with Display Units, Metric SI, Region for Default Materials India, Steel Section Database Indian, Steel Design Code IS 800, Concrete Design Code IS 456, and click on OK. You will get a new model quick template. Then click on Custom Grid Spacing, Edit Grid Data. As we have seen in the continuous beam with the different spannings, AB is having 3 meter and BC is having an 4 meter. So we are adding it up with 3 meters. So it is 7 meter. And CD is having a span of 4 meter. Total 11 meters continuous span. And there is no stairs. That's why we are deleting the Y grid data and click on OK. And number of stories are 1. And select grid only and click on OK. Now define the materials, add new material, steel Fe250, and click on OK. And these are the material property for steel. Add new material, concrete. In concrete I am choosing M20 grade concrete and click on OK. And this is the material property for M20. Add new material, that is rebar, that is mild steel 250, and click on OK. This is the material property for a rebar and click on OK and then OK. We have completed the material property. Then moving on to the section property, frame section, add new property, consider a rectangular concrete block and give a naming for this one as continuous beam. And we have chosen the material as M20. So take it M20 here and then 300 mm by 300 mm. Then reinforcement, modify the show rebar. As we are designing for the continuous beam, click on beam and longitudinal bars are a mild 250. Longitudinal bars can be chosen as a HYSD 415 and top cover is 30 and the bottom cover is also 30 and click on OK and then OK. Now draw the beam, quick draw beam, and here near the property change the property as continuous beam what we have given. After that also use the cursor for assigning the property and click on escape, then you'll get the regular cursor. Assign joint connections. The first one is fixed, second one is hinged, and the third one is roller. As the continuous beam has having a fixed ends at the end and the roller support at the middle. So click on fixed support, select grid point A1 and apply. Then grid point at D and apply. And moving on to the roller support, click on roller support and select B point and apply, C point and apply, and then click on OK. Assign point load for the first span. Click on absolute distance from end one. AB is having a point load at a distance of 1 meter, so we are giving 1 meter and the load is 80 kilonewton. So select the beam AB and click on apply, and again the BCD span is having a 40 kilonewton at a span of 2 meter. Select the beam CD and click on apply, then click on OK. Assign distributed load, that is BC is having an 50 kilonewton per meter. So select BC beam and click on apply and then OK. Here you can see the support conditions and the loading conditions for the continuous beam. We have completed assigning the concrete properties also. So we are going for model check. Then click on OK. The model has been checked. There are no warnings. So we can run for analysis. Create a new folder. As continuous beam. Click on save. So this is the displacement. Here you can see an arrow button, add new window, and in display, force or stress diagrams. In this already we are having displacement, so no need to go in it. Display, moment, and show the values and click on apply. Here you can see the values and click on OK. You can use this symbol, and again there is a drop down here, add new window, display, shear, apply, then click on OK. So we have completed the analysis of a continuous beam in Etabs. You can see the displacement and you can see the shear force and the bending moments. If you want to rotate that one, here you can see a symbol rotate 3D view. So you can rotate this beam. Again select that one and rotate that beam. You can minimize or maximize using the so you can see the values of bending moment and shear force in this. Thank you.